To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all current electricity. This is the 19th lesson of your grade 10 science textbook. And as you all know, this is a physics lesson. You are familiar with current because in your day-to-day life, in your household, in your school and most of the places you all go, there is some equipment that uses electricity. So you all know it is a very important thing in our day-to-day life, that is current, electricity. And it is a form of energy, electrical energy. So we will be discussing certain properties and relationships related to current electricity in this lesson. With that introduction, we'll look at the contents of this lesson. Current electricity. So under that, first we will be looking at static electricity and current electricity. You all know the meaning of static. Something that is stationary, that does not move. So there are charges in matter, and because of that, there is charge or there can be charge generated in some objects. And if it does not move, it's known as static electricity, and when the charges start flowing and the current starts flowing, then it becomes current electricity. So we'll be discussing that first. Then we have electricity flowing through conductors. You all know materials that conduct electricity or through which electricity can pass. For example, the copper wires that you use at home, the conducting wires, current wires. So we will be discussing how electricity flows through conductors and the properties of conductors. And also then we will be discussing potential difference and the electromotive force. The force that drives the current electricity to flow. And the potential difference that causes current electricity to flow. That is the charges to flow. Then we have the relationship between the current flowing through a conductor and the potential difference across the conductor. So usually there is a relationship because the potential difference drives the charges to flow. Because of that, current flows. So we will be discussing that relationship. Then factors affecting the resistance of a conductor. Now as you know, conductors are materials that allow current to pass. But still, all matter is made up of atoms. Atoms have charges. So that means every matter that acts as a conductor resists the flow of current. That is where we have the resistance of a conductor. So we will see what resistance is and then the factors affecting resistance. Then the next one is resistors. In order to control the current flowing through a circuit, we can use resistors. So to reduce the current or adjust the current, you can use resistors. And these resistors are available in different forms and also they can be connected in different forms. So that is where we consider the combination of resistors. So those are the contents of this lesson, students. Now we will move on to the lesson. Static electricity and current electricity. So as I told you all, the meaning of the word static. Usually static means stationary, something that is not moving. So electricity is related to charges. So here, charges that do not move. Any matter that has additional charge or that becomes charge and the charges are not moving means that is considered as static electricity. Then current electricity, of course, the charges flowing and therefore current flowing through a conductor. We will discuss both these, static electricity and current electricity. electricity is a very important form of energy to us. So as I told you all, electricity is an important form of energy, electrical energy. In the modern world, many instruments are manufactured in a way that they could be operated using electricity. You are familiar with that. Now you all are looking at the smart board. You are watching this video through the laptop. Now laptop, computers, PCs, any type of computer or the smart board. Then you are in a place where there are light bulbs. There can be a fan, electric fan. All these use electricity. You all iron your clothes using an electric iron. Then you all have electric rice cookers at home. Cook rice. Then to heat water, you can use an electric kettle. Then there are electric cookers. Like that, there are so many equipments or instruments that use current electricity. So as examples, we can say electric bulbs, then electric fans, then electric iron, electric cooker. Like this, you can keep on listing instruments and equipments that use electricity, even computers. So there are so many forms. They all use current electricity. That is the current flowing through conductors. That is why in all these instruments we have the power cable, so that you can connect it to the power supply through which current will flow. Of course, instruments like computers, they do have the battery, so they can work on battery also, but there again, there is current electricity. So they all need current electricity. And this electricity basically has two forms, what we discussed before the heading. The two forms of electricity are static electricity and current electricity. So electricity basically has two forms, static electricity and current electricity. So as I told you all, there are two forms, and static electricity is the charge that does not move. So first we will discuss what static electricity is, and then we will move on to current electricity. So with that, students, I will move on to the next slide. So as we discussed, students, there are two types of electricity. One is static electricity, the other one is current electricity. So static electricity. Now you have learned this in your previous grades. There are insulators and conductors. What are conductors? Materials that allow electricity to pass through them easily. Whereas insulators, those are materials that do not allow electricity to pass through them easily. So you all know metals like copper, iron, almost all the metals, and even graphite. They are very good conductors of electricity. Whereas substances like wood, plastic, ebonite, all these PVC, polyvinyl chloride, PVC, these are insulator materials. Even different types of materials are insulators. Pure water does not allow electricity to flow through it. So when we say static electricity, it is the electrical charge, the charges that are formed on the surface of an insulator. So for example, if there is a plastic material, if you have a plastic material like that, if there are charges, let's say positive charges formed on this. Or another material, it can get negatively charged. Now, when there are charges that are deposited on the surface of an insulator, very important, insulator, then we call it static electricity, insulator. So, the surface of the insulator can either become positively charged or negatively charged. Static electricity consists of charges that are deposited on the surfaces of insulators and that they do not flow. So, they don't flow, they don't move, they are stationary. That is why we say static electricity. So, as insulator materials, we can consider a few examples: plastic, ebonite, then we can take, we can consider plastic, ebonite, even PVC. All these are different insulator materials. So, when we say plastic, we can take a plastic straw, a comb, all these are objects made up of plastic. Then ebonite, you all know what ebonite is, ebonite rod. And ebonite is used in legs of furnitures and also in sometimes door knobs. Then PVC pipes. So, these are some examples of insulators. So, how do you get this charge deposited on the surface of these materials? When you rub these insulators, rub them with another material. So, when we say rubbing them with another material, it can be a piece of polythene sheet, it can be a wool material, a cotton material, those can be used. So, here are examples: cotton cloth, then it can be wool cloth or polythene sheet. So, plastic, ebonite, PVC, these are examples of insulators and these are examples of materials that are used to rub them: cotton, wool and polythene. So, let's say you take plastic and you rub it nicely with a polythene sheet. Then, if you hold it near tiny pieces of paper, tiny pieces of rigiform or even dust particles, they will get attracted to it. So, that shows that there is static electricity produced. So, when we say static electricity, there should be an insulator and there is charge deposited on the surface of this insulator and the charge does not flow. So, that is why static electricity. I am sure you can understand that. So, now we will move on to the next slide where we look at some examples or instances where we come across static electricity or where we can generate static electricity using an insulator and a material to rub on it. So, this is a simple activity which you all have learnt in smaller grades also. So, if you look at the picture first, you can see here there is a drinking straw. Usually drinking straws are made up of plastic. So, it's a plastic straw and there is a piece of cotton cloth. So, what we do is we take the straw, we nicely rub the straw with cotton cloth. And you all know normally when we rub it in one direction. That's more better. So, once you rub it, then if you hold the straw near very tiny pieces of paper, then you will see that the pieces of paper get attracted to the straw. Or else what can you all do? You can rub 2 straws with piece of cotton and then if you bring the two straws close to each other, you will see them repelling. But without rubbing, if you hold a straw near pieces of paper, nothing will happen. If you hold two straws near each other without rubbing with a piece of cotton, then also there is nothing. So only when you rub the drinking straw with a piece of cotton cloth, there is a charge generated. And this charge is what we call as static electricity. And due to that charge, the tiny pieces of paper get attracted to the straw. Now we will look at the explanation there. So here you can see, rub a drinking straw well with a cotton material and bring it close to tiny bits of paper as shown in figure. You will observe that the bits of paper get attracted to the straw rubbed with piece of cotton cloth. So if you don't rub the straw, nothing will happen. It will not attract the pieces of paper. But after rubbing it with a cotton cloth, then it will attract the pieces of paper. Also, bring another straw that was not rubbed with a cotton cloth close to tiny pieces of paper. You will notice that the bits of paper would not be attracted to the straw. So that is the observation. A straw not rubbed with cotton cloth does not attract tiny pieces of paper. What is the reason? Now, if you take a straw or any matter, now they are all made up of atoms. You are familiar with the concept of atoms. What are atoms? The building units of matter. And you all know in atoms there are charged particles, subatomic particles, electrons, protons and neutrons. So now in these atoms, the electrons are negatively charged, protons are positively charged. What happens is these have equal number of positive and negative charges. So in this rod there is negative charge that is equal to positive charge. Number of charges are equal. Charges are equal. But what happens when you rub it with a cloth or some other material? Some of the charges from the straw can flow to the cloth, or from the cloth, some charges can flow to the straw. Either way, straws can lose negative charges or they can gain negative charges. Because you all know electrons are the only particles that can move from one atom to another atom. Positively charged protons cannot move because they are within the nucleus. We will discuss the atomic structure in the next few slides. But for now, you all are familiar with this concept. Electrons are in orbitals, shells or energy levels. So they can go from one atom. They can move. But the protons, which are positively charged, they cannot move. So when you rub a cloth with straw, either electrons can come from the cloth to the straw or they can go from the straw to the cloth. So because of that, there will be a charge. Now here, of course, the plastic straw gets positively charged because electrons flow from straw to cotton cloth. So when you rub it, the electrons flow from the straw to the cotton cloth. So the straw becomes positively charged, and because it is positively charged, it can attract the tiny pieces of paper. And here, if you take the straw that is positively charged, and now this positive charge cannot flow or does not flow. It is present on the surface of the straw. So those charges are what we call as static charges. And that is why this is known as static electricity. So these charges is what we call as static electricity. Static electricity. I'm sure you all can understand that concept. Okay, students. So now we will go to the lab and we will have some insulator materials. We will use those insulator materials and other materials to rub on them and see how they get the static electric charges and how they attract tiny pieces of paper and tiny pieces of regiform. Okay, students. So I'm going to do this activity to understand what static electricity is. You are familiar with this concept. You all know that insulator materials, because of charges on the surface of these insulator materials, they can attract very light particles like regiform pieces, tiny pieces of regiform, tiny pieces of paper, or even dust. So here I have some insulator materials. You are familiar with this, a plastic comb, the plastic tube of a pen, a straw, then the ebonite rod here and the PVC pipe. These are all insulator materials. And to get the static electric charge on the surface of these materials, we need to rub them with another material. When you rub a comb either on your hair or on a piece of cloth or piece of polythene sheet, then the static charges will be generated. So to rub these materials, I have a piece of polythene sheet, a piece of wool and a piece of cotton cloth. So we will try this activity and see how these charges attract these particles. So if I take this comb, if I hold it near these regiform balls or the tiny pieces of paper, it does not get attracted. Now you can either rub it with on your hair, the hair should be dry, not oily, or else we can rub it with a piece of polythene sheet. So when I rub it, we have to rub it nicely, and if you hold it near pieces of regiform, here you can see the pieces getting attracted there. So that is due to the charges generated on the surface of the insulator. That is the static charge. Now same thing we can try with pieces of paper. If I hold it here, now you can see the pieces getting attracted to it. Can you all see the pieces attracted? So that is again due to the static charges. Now how do these charge occur? The static charge generated. Comb is made up of atoms. It has electrons, negative charges. Now when I rub it with a sheet of polythene, negatively charged electrons flow from one material to the other. Because of that, there are charges generated on the surface of this comb. And those charges do not move. Because of that, we call them as static electric charges, and those are the charges that attract these substances. Now we can try the same thing with a tube of a pen. That also can be used to do the same activity. Now if I hold it near regiform balls or pieces of paper, there is no attraction there. But if I rub it with polythene, now if I hold it near pieces of Regiform, you can see they get attracted to the pen tube. Same thing we can try with pieces of paper. Here also the pieces of paper get attracted. So that's again static charges. So here again I have a straw, a plastic straw that also can be used to do the same activity. We can rub this with a piece of cotton cloth or with a piece of polythene sheet. So first we'll see whether it attracts Regiform balls and paper. Now if we hold it near Regiform balls or pieces of paper, it does not get attracted. But if I rub it with a polythene sheet, now if I hold it near Regiform balls, you can see they get attracted. So that is again due to the static electric charges formed on the surface of straw. Now again pieces of paper, you can see they get attracted to the surface of the straw. So that is also due to the static electric charges formed on the surface of the straw. So these are all insulator materials. Then I have here Nebonite rod. Now this also can be used as the insulator material. If we just hold it near Regiform balls or pieces of paper, there is no attraction. But when I rub it with a piece of woolen cloth or wool. Now here if I rub it nicely and you hold it near Regiform, here you can see they get attracted. Same thing we can try with tiny pieces of paper. Here you can see the pieces of paper get attracted. Here you can see. So all these are due to the static electric charges formed on the surface of these insulator material. Comb, tube of a pen, straw, ebonite rod. And also I have a PVC pipe here. Now if I hold this also near pieces of Regiform and pieces of paper, nothing happens. Now here you can see it does not attract any of these. But if we rub it with a sheet of polythene, so here if we rub it nicely with a sheet of polythene, and if I hold it, here you can see it attracts tiny pieces of Regiform. So like that students, we can use different insulator materials. We rub them with different types of cloths or different materials like polythene sheet, wool and also cotton cloth. You all can understand that there are charges formed on the surface of the insulator and that attracts these tiny substances. They have to be very light. That's why we use tiny pieces of Regiform, tiny pieces of paper. Even dust will get attracted to these surfaces. So that is static electricity. Charges that do not move and that are formed on the surface of insulator materials. You all have to understand that, students. Okay, students. So now that you have observed the activities, so you saw how materials become charged and how they attract tiny pieces of paper and Regiform. So that is something you have already learned and again you have seen it now. So with that, I'm going to move on to the next slide. So another example. Again, look at the diagram first. Now here there is a comb. Now you can use a plastic rod, a comb or a plastic ruler. Anything, you take a plastic object and you have to have very dry hair, not oily hair, and you rub the comb on your hair. You can either keep on combing it or you can just rub it. And then you hold the comb near tiny pieces of paper or tiny pieces of Regiform. And there also you will see that the tiny pieces of paper or Regiform get attracted to the comb that was rubbed with your hair. But if you just take a comb without rubbing with your hair and hold it near tiny pieces of paper or tiny pieces of Regiform, nothing will happen. It will not attract those tiny pieces. Only after rubbing with your hair, you will see that the particles get attracted. So here also the same thing. Now if we take plastic comb or plastic rod, they are made up of atoms. There are charged particles, electrons and protons, and from there electrons can move from one place to the other. And when you rub the comb with your hair, what happens is electrons come from your hair to the comb. Comb gets negatively charged. So here comb gets negatively charged. And this negatively charged comb attracts the tiny pieces of paper or tiny pieces of Regiform. Again, the charged surface, the charges that have been induced is what we call as static electricity. Now if we read, rub. So here you can rub a plastic rod, a pen or a comb against your hair and bring it near tiny bits of paper or tiny pieces of Regiform. Either one is fine. You will observe that these tiny pieces being attracted to the items rubbed with hair. Figure shows little bits of Regiform being attracted to a rubbed comb. So that is what I explained to you. Try the above with a plastic rod that was not rubbed with hair. There you will observe that the Regiform pieces do not get attracted to it. So there, of course, the Regiform pieces are not attracted. If you don't rub it with your hair, then pieces of paper or pieces of Regiform does not get attracted. But once you rub it on your hair, then you will see the particles, the pieces getting attracted. So from that, you all can understand when you rub either straw with a cotton cloth or a plastic comb on your hair, there are charges formed. And those charges do not move, but they can attract tiny objects like pieces of paper or pieces of Regiform. And those charges are what we call as static charges because they don't move. But you all have to remember, students, you have done this before also. If you touch it with another object, then of course the charges will flow. For example, you have this plastic comb, you rub it on your hair, that will get charged. Then you have another comb that has not been rubbed, and if you touch both the combs, then of course charges from the rubbed comb will flow to the other comb. So they can flow, but normally as you rub it, they are static, they don't move. That is why we call it static electricity until they are in contact with another object. I'm sure you all can remember that because you have done similar activities in your smaller grades also. So with that, I'm going to move on to the next slide. When some objects are rubbed, they acquire a force to attract little pieces of paper, dust and other light materials. So here, important thing because we are using tiny objects. They can attract very light materials. Such objects acquire this attractive power through the static electric charges generated by rubbing. So they acquire this attractive power from the static electric charges. So static electric charges, charges that do not move. You have observed that objects such as a drinking straw or a comb attract tiny bits of paper only after rubbing them, and if the objects are not rubbed, they cannot attract bits of paper. So I explain this concept to you all. Now, when you have a normal object and we have another one of the same object, so here not rubbed, positive and negative charges are equal. When rubbed, they become positively or negatively charged. So that is what happens here. When they are not rubbed, they have positive and negative charges, but in equal number. So that is why normally we say matter is electrically neutral. Why? Because atoms are electrically neutral. They have equal number of negative charge electrons and positive charge protons. But when rubbed, these electrons flow from one material to the other. Because of that, the object either become positively charged or negatively charged. Like we discussed before, the straw becomes positively charged, whereas the plastic comb becomes negatively charged. I'm sure you all can understand this concept clearly. So then we'll move on to the next slide. So how are static electric charges that give certain objects an attractive power generated? So again, something that I already explained to you all. How is this charge generated? The static electric charge, how is it generated? So to understand that, again we'll recall what you have learnt before, the structure of an atom. So here, all materials are composed of atoms. That is why we say atoms are the building units of matter. So these are the building units. And these atoms consist of tiny particles known as what? They are the subatomic particles. Subatomic particles. And you all know there are three subatomic particles. What are they? Electrons, protons and neutrons. So here there is electrons. Normally we use the symbol E, and this is negatively charged. Then we have protons. Protons, we use the symbol P, and they are positively charged. And we have the third subatomic particle, neutrons, usually simple N, and they are neutral. Neutral particles, or we can say not charged, or they do not have a charge. So there are three subatomic particles, electrons, protons and neutrons, and out of that electrons have negative charge, protons have positive charge, and neutrons are the neutral subatomic particles. And these are the symbols that we normally use. Simple E for electrons, simple P for protons and N for neutrons. And these subatomic particles are arranged in a certain manner in atoms. So that is what we call as the structure of atoms. You all can remember the structure. What is it? Now if you take an atom, normally it has the nucleus. So if we just consider the basic structure of atom, here you have both neutrons and protons, and this is known as the nucleus. So the nucleus, since it has the positively charged protons, nucleus is also positively charged. And that is a very tiny part of the atom. And around that there is lot of space, and within that space you get electrons. So here we get electrons present in energy levels or shells. So here we will get the electrons. Protons and neutrons are there in the nucleus. Electrons are there in energy levels. And you all are familiar with the different energy levels, the different shells, K, L, M, N, and how many electrons can be present, the maximum number of electrons that can be present in each of these shells, and the way to organize them, the electronic configuration. I'm sure you all can remember all those concepts. So that is the model of an atom. It was initially proposed by Ernest Rutherford and then the Niels Bohr model. So this is basically the structure that makes up all matter. And out of these, now see, nucleus contains both neutrons and protons. So protons are confined to the nucleus. Because of that, they cannot move. That is why you all can remember atomic number is considered as the number of protons. Although protons and electrons are present in equal number, when we define atomic number, we say number of protons because they do not change for a particular atom. Whereas electrons that are present in energy levels or shells, they can easily move from one atom to the other atom. So that is why ions are formed. So because of that, the electrons are known as free electrons or mobile electrons. They can move. They can be lost or gained. That is the basic structure of atom. Again, in the next slide also, there is a diagram, a figure regarding this structure of atoms. We will discuss that and then we will continue with the rest of the slides. So here you have the structure of atoms. Now here you can see this is the nucleus where you have the positively charged protons and the neutral neutrons. And then you have the electrons. Now around the nucleus it is a wide space. But for our convenience, the path in which electrons move are considered as the shells or energy levels. So electrons move in shells or energy levels. So that is the structure. You can remember the scientist who proposed the structure also, the planetary model by Ernest Rutherford and also Niels Bohr structure, where he discussed about energy levels and all that. So we are not going to go into detail. The important thing that you all have to remember here when it is related to static electricity or current electricity is that the electrons that are present in the shells, they can go from one atom to the other. But the protons, which are positively charged, and the neutrons that are neutral, they cannot move from the nucleus. They are confined within the nucleus. That is the important thing. I'm sure you all can remember all these and you can understand the basic concept. So with that, I'll move on to the next slide. If electrons are removed from the atoms on the surface of an object after rubbing it with a piece of cloth, positive charges are generated on the surface of the object. So here, if electrons are removed, then positive charges are generated. That is, the surface is positively charged, like the straw. If the object receives electrons from the piece of cloth after being rubbed with the cloth, then the surface of the object acquires a negative charge. That is, the surface gets negatively charged. And here the surface gets positively charged. So you can remember those two activities. So as an example, if you remember, straw rubbed with cotton cloth gets positively charged. Then comb rubbed on hair gets negatively charged. Similar to this, you can think of other examples as well. A PVC pipe rubbed with polythene. You all have done this activity before. PVC pipe rubbed with polythene gets negatively charged. So this is how charge flows from one object to another object or one surface to another surface when one object is being rubbed with another material. So when you rub a straw with cotton cloth, it gets positively charged. Then what happens? The electrons from the straw flow to the cotton cloth. That is why the surface of the straw becomes positively charged. Less electrons and the same number of protons remain inside the nucleus of the atom, but the electrons have moved from the straw to the cloth. But in the second instance, that is the first instance, in the second instance, where a comb is rubbed on the hair, the comb gets negatively charged. There what happens? Electrons from the hair moves to the comb. So comb receives electrons. Again, the third instance, PVC pipe rubbed with polythene, that also gets negatively charged. So there are also electrons from polythene move to the PVC pipe or flow to the PVC pipe. So that is where the charges are generated. On the surface of the PVC pipe, on the surface of the straw, on the surface of the comb, or even with balloons. You have done that activity also. You have the fully blown balloon and you rub it with a cloth and it gets charged. So in all these surfaces, in all these materials, the surfaces become charged and those charges remain on the surface. That is what is known as static electricity. I am sure you all can understand that concept clearly now. With that, students, we will move on to the next slide. Charges that are found stationary on an object in this manner are known as electrostatic charges. When such accumulated electrostatic charges begin to move, they give rise to an electric current. So, for example, now we have an object. Let's say a PVC pipe. Now when you rub this PVC pipe with polythene, PVC pipe rubbed with polythene. Then the surface gets negatively charged. There are negative charges on the surface. Here, these charges are known as static charges, or we call them as electrostatic charges. Now at this point, now this is just an object, a PVC rod, and it has charges. The charges are not moving. So because of that, we call them either electrostatic charges or static charges. Electrostatic, static is because it doesn't move. Electro because it can lead to current flow. So that's why electrostatic charges. Now if you connect this, now if we take this PVC pipe and say we connect it to a conducting wire and a bulb and to another source, let's say to the earth. Now if we connect it to conducting wires, then a bulb, and here earth. So earlier there were charges here. Now you have created a path for the charges to flow. Then the charges will start flowing. The negative charge will flow. So charges or charge flows. What will you see? The bulb will light. And at that time, when the charges are flowing, we call it current electricity. So initially we had the PVC pipe with the charges that did not move. That is static electricity. But when you connect it to a path, that is what we call as an electric circuit, through which these charges can flow, then the electric charges flow through it. So that is what we call as electric current. So here, of course, it becomes current electricity flows through the circuit or the path. So that is what happens. Now can you all understand the relationship between static electricity and current electricity? These are basically charges, either positive charges or negative charges. When the charges are not moving, it's known as the electrostatic charge. And that charge is what we call as static electricity that can attract other tiny objects. When the charges, the electrostatic charges, attract tiny objects, we call that the force that attracts the tiny objects is known as the static electricity. But if we provide a path like that, the static charges start flowing through that material. Then we say that there is current flow. And that is what is known as current electricity. So when it does not move, it's static electricity. When it moves through matter, we call it current electricity. And usually, the matter or materials that conduct electricity, that allow current electricity to flow through them, are known as conductors. So static electricity, the charges can flow through conductors, then it becomes current electricity. Now we will try to do an activity to understand this concept. Activity. Find out how to generate an electric current from electrostatic charges. So how you can generate an electric current from electrostatic charges. So static electricity and current electricity. To do this, we need these materials. Here we need a PVC pipe. You can see from the picture. Then we need polythene. So like I said, you need to rub the PVC pipe with polythene. So what will happen? The PVC pipe will get negatively charged. And thereafter, we need a bulb or an LED bulb. LED is connected, or neon bulb can be connected, and we need conducting wires. So this is what we will be doing. We might also need a stand. We might need a stand to hold these. So students, these are the materials that we need. We need a PVC pipe, the polythene sheet, so that we can rub the PVC pipe with polythene sheet. It will become charged. Then the bulb to see whether there is current flowing, and then we need conducting wires to connect the circuit, and also we might need a stand to fix the bulb. So those are the materials that are required. Now we will move on to the next slide where I discuss the procedure with a diagram. So here, this is the procedure. Like I said, you all can see here, students, this is a PVC rod. Now, if you initially take the PVC rod, connect it to one end of the wire, and here we have the neon bulb, and then we have the other terminal connected to the earth. Now, this symbol is something you all need to remember. This means that the terminal is connected to the earth. So here, initially without rubbing the PVC rod with anything, if you connect it like that, there will be no change. That means the neon bulb will not light. But what we do is, this is not permanently connected, you just touch it with the wire. So what you do is, you take the PVC rod, you rub it nicely with polythene, and then you bring it in contact with the wire. As you touch the wire, you will see the neon bulb light. And it's only for a small time period. After that, the bulb will go off. As you touch the wire, the bulb will light, and then after some time, the bulb will go off. What is the reason? Now, charges are formed here when you rub it with polythene. Then the charges can flow through the bulb, and because of that, the bulb will light. But here, the other end is connected to the earth. So because of that, the charges will flow to the earth. Bulb will go off. Then what we do is, again we remove the PVC pipe, again you rub it with polythene, again you connect it to the wire. You will see the bulb light, and then it will go off. Like that, you can repeat the procedure many times. So from that, you will be able to understand that when we rub the PVC rod with polythene, there is static electricity or electrostatic charges generated, and when that is connected to this path, the conducting wires, bulb, and connected to the earth, the charges flow. So that flow of charges is what we call as current electricity. So the electrostatic charges flow through the conducting wires and the bulb to the earth, making current electricity. So the two instances. I am sure you all can understand the concept. And so before we go to the lab and do the activity, I will read the procedure for you all again. Arrange the setup by connecting the conducting wires to the neon bulb as shown in the figure. Connect one terminal of the neon bulb to the earth. So here you can see one terminal is connected to the earth. Charge the PVC rod by rubbing with polythene. So you charge the PVC rod by rubbing with polythene. Touch the terminal of the neon bulb with the charged rod. Repeat the above step several times and observe the lighting of the neon bulb. So the lighting will happen and it will go off. It will come on as it is touched, then it will go off. So from that, you can understand the relationship between electrostatic charges and current electricity. So I'm sure you all can understand this simple activity. So let's go to the lab and do the activity now. Okay, students. So now I'm going to do this activity in order to understand how electricity flows, that is electric current, can be generated from static electric charges. So as you all know, when we have an insulator material, if we rub it with another material, for example, a PVC pipe is an insulator material. When we rub it with a sheet of polythene, there are static electric charges formed on the surface of PVC. So if we connect those charges to a conductor, then of course the charges can flow through the conductor and that will become the electric current. So to do that activity, we need a neon bulb. So here I have a neon bulb and the two terminals of the neon bulb are connected to conducting wires, copper wires. So similar to that, here I have another neon bulb. I have attached it to the surface so that it won't move while I do the activity. And here I have connected the two terminals to copper wires. And on this side, I have a long wire that is connected to the earth there. So it's a long wire. Whereas on this side, I have the terminal with the open end. So this is what we are going to do. I'll be taking the PVC rod. I'll rub it with a polythene sheet. Then after rubbing it, I will touch the conducting wire on this end because this end is connected to the earth. So here, if I just touch it, now you can see nothing happened because there are no charges on the surface of PVC. So there are no charges flowing through the neon bulb. And you all have to remember, students, even a very small amount of charge, that is the static charges generated on the surface, is enough to flow through the neon bulb and to make it light. There are different types of neon bulbs, but this one, it can light with this small amount of charges. That is why we use the neon bulb. So now I'll be rubbing this with the sheet of polythene and then I'll be touching it here. And then I will have to touch it to the conducting wire. Here can you all see the light? It came on and immediately it went off. So that is how it happens. I rub the PVC rod with polythene sheet. There are charges generated on the surface of the PVC pipe, that is the static electric charge. When I touch it on this conducting wire, the static charges flow through the copper wire and through the neon bulb to the earth on the other side. So there, when the charges flow through the conductor and the bulb lights, it is the electric current. So that is when charges flow through a conductor. So can you all understand the two types of electricity? Static electricity on the surface of an insulator. But when that is in contact with the conductor, the electric charges flow through the conductor and the bulb lights. That is the electricity that flows. So current, electricity. And why does the bulb go off? Because there is a small amount of charge on the surface and that also flows through the conductor to the earth. So that is why until the charges flow, the light is on. When the charges are not there anymore, not flowing anymore, the bulb turns off. So that is how we can convert static electricity to current electricity. I'm sure you all can understand that, students. Okay, students. So you all saw the observation of the activity. What happened there? When I rub the PVC pipe with polythene sheet and then when I touch the conductor, you saw the neon bulb light and within few seconds, you saw the light go off. I repeated that procedure again. Again also the same thing happened. So you were able to see that clearly. That was the observation. So here if we write down the observation, the neon bulb lights for some time as the PVC pipe rubbed with polythene comes into contact with the conducting wire. So the neon bulb lights only for some time. So what is the reason for that? Now you can remember the activity. We have the connection one end of the bulb, one terminal of the bulb is connected to a conductor that was connected to the earth. To the other end only, I touched the PVC pipe that was rubbed with polythene. So what happens there? When you rub the PVC pipe, there are charges formed on the surface, that is a static electric charge. And as I touch the conducting wire, charges from the PVC pipe flow through the conductor, through the neon bulb to the earth. So until that flows, the bulb lights. Once all the charges flow away, then there is no charge flow, therefore there is no current. That is why the light goes off. So that means the charges that were present on the surface of PVC as static electric charges, when connected with a circuit, a complete circuit, they can flow from one point to the other. So the static electricity now becomes current electricity. So current electricity, as you all know, is the flow of charges. Static electricity, charges deposited on the surface of insulator materials. But current electricity, charges that flow through conductors. So that is what you saw here. So as conclusion, we can say, when a material with static electric charge comes in contact with a conductor, then the charges flow through the conductor. That is, in the activity static electricity is converted to current electricity. What is current electricity? Charges that flow through a conductor. So charges that flow through a conductor. So that is what you were able to see from the activity. Here, this is something you all have to note down and understand. I have already told you all this. The neon bulb lights only until the charges flow from the PVC rod to the earth. So, the neon bulb lights up only till the charges from the PVC pipe flows to the earth through the conductor. So, if you want current to flow continuously, then of course you will have to supply a power source that can provide continuous flow of charges. So usually the materials are made up of atoms, and the atoms have protons and neutrons in the nucleus, and electrons are the ones who are moving in the shell. And the electrons are the materials that can flow. So there should be a source that can supply electrons to flow through a complete circuit. And then electric current will flow through the circuit. That is what we call as current electricity. I'm sure you all can understand that. So you know the difference between static electricity and current electricity. Static electricity, there are charges deposited on the surface of insulator materials, and these charges do not move. But when there are charges that flow from one point to the other, then there is current electricity flowing through the material. Is that clear to you all? So then we will move on to the next slide. So students, this is again related to what we saw during the activity. Now you all have a good understanding about electrostatic charges and current electricity. Charges that do not flow are electrostatic charges. When they start flowing through a conductor, we call it current electricity. That is what you observed in the activity also. So the conclusion that we came to is again repeated here. Electrostatic charges are stored on the surface of the PVC rod rubbed by polythene. So that is electrostatic charges or static electricity. When it touches the conducting wires, the stored static charges begin to flow out via the conducting wires. Through the conducting wires, the stored static charges start to flow. When these charges flow through the neon bulb, it lights up. So here you can see, when the charges flow through the neon bulb, it lights up. Neon bulb lights up. And when static electric charges begin to flow in this manner, it is known as an electric current. That is very important. When static electric charges begin to flow in this manner, it is known as an electric current. This is something you all have to remember. So when the electric charges don't flow, we call it electrostatic charges or static electricity. But when it begins to flow in this manner, it is known as an electric current. So if you are asked the question, what is electric current? What will you all write? You can say a current of charges flowing through a conductor is known as electric current. So here we can say a current of electric charges flowing through a conductor is known as electric current. So I'm sure students, now you all understand what static electricity and current electricity are. And also you all are familiar with electrical circuits and the circuit symbols. So for example, if you take a battery, now you all know the symbol for battery. This is the symbol. And here you can remember this is the positive charge terminal and that is the negative terminal. So we connect this using conducting wires, and there you can have a switch, and also we can have a bulb connected there. So these are batteries or battery. Then this is the conducting wire. Then a bulb and switch. Now here you can see the switch is open. Switch open, or you can say off. Then of course there will be no charge flowing through this circuit, or there is no current, electricity flowing through this circuit. So you will not see the bulb light. But when you connect the circuit, that is, you on the switch, then of course the charges will start flowing through these circuits, that is the conducting wire and the bulb. So then you will see the bulb light. So here of course the battery is the power source, the source that provides electricity when the circuit is complete. So from there the electric current flows through the circuit and the bulb lights. So that is current, electricity flowing through the circuit. So in this I just wanted to recall all these circuit symbols. You are familiar with most of them: the battery, the bulb, the switch, the conducting wires, and also you are familiar with series and parallel connections. So that is something that you have learned before also. So with that students, I am going to finish this chapter, but again when I start the next chapter, I will discuss about conductors. So this conducting wire is also a conductor. Metals are very good conductors of electricity. We will be discussing about those conductors, and then again we will be drawing circuit diagrams, and also we will be discussing about different types of connections. Like I said, the series connection and the parallel connection. So with that students, I am going to end this chapter.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.